I wanted to look at a couple more examples of linear inequalities. So starting with this one here, it has some decimals in it. So one approach that you can take is to try to cancel all of the decimals. Now I have, let's see, 0.1, 0.5, and 0.2. I know if I multiply those three numbers by 10, they'll just become integers. So I'm going to do this as my first step, where I'm going to multiply both sides of this inequality by 10. So on the left, I'm going to put 10, open up parentheses, and I'm going to do the same thing on the other side and just place both sides in the parentheses. So 0.1 times x plus 9 plus 0.5 times 2x minus 4. It'll be greater than, and then I'm going to have 0.2 times 1 minus x. So one key thing to point out here is the greater than still holds true because I multiplied both sides by a positive number. The only time that this would change directions is if you multiply or divide both sides by a negative number. But that hasn't happened yet, so let's move forward. I'm going to take this 10 and distribute it to both of those terms. Here, I can just multiply it directly into this 0.2, and let's see what's left over. For this very first term, 10 times 0.1 is just 1, so I'll put, okay, this is 1 times x plus 9. Then I'm going to have 10 times 0.5 is 5 times 2x minus 4. I still have greater than, and on the right, I have 10 times 0.2, which is 2, and then 1 minus x. So this step was just to get rid of all of the decimals. If you want to skip a step, you really can just look at the 0.1, the 0.5, and the 0.2, move the decimal over once on all of them, and we'd end up at this step right here. So it's however you choose to write it. Okay, so for the next step, I'm going to distribute into the parentheses. And here, if it's just a positive 1, I'm not going to change the x plus 9, so I get x plus 9. Now here, if I distribute in the 5, I get 10x minus 20, still greater than, and then I have 2 minus 2x. So I think as my next step, I'll combine some like terms. So let's see, on the left, I have x and 10x, okay? So that's going to be 11x. And then I also have negative 20 plus 9, so I'll combine that at the end. So negative 11. And on the right, I still just have 2 minus 2x. Okay, so at this step, you could go in two directions. You could either add this 2x to this side, moving the 11 over here, or vice versa. You could subtract this to the x here, move the numbers to the left side. If you want to avoid the problem of dividing by a negative, what I would do here is add 2x to both sides of this inequality. When I do that, I get 13x minus 11 is greater than 2. Okay, now I'm going to add 11 to both sides. And I get 13x. That still is greater than 13. And our very last step is going to be to divide both sides by the number in front of the x, which is 13. And when I do this, I end up with x is greater than 1 as my final answer. So what happened here is I set it up so when I divided both sides by the same number, I was dividing by a positive amount. So I still had x is greater than instead of less than, and this is our final answer. And for example 2, same idea, solve an inequality, but now I'm using fractions instead of decimals. And I think I said in class that the approach I like to take is to multiply both sides by the least common denominator. So I'll mark that off to the right here, where if I want the least common denominator, I'm looking at the numbers 3, 5, and well, 5 one more time. I know those numbers share nothing in common. It's got to be the product of 3 and 5. That's my least common denominator. So I'm going to go through and put in this kind of extra step in the middle where I multiply every single term by 15. So as my first step, I'm just taking 15 and multiplying it to the entire left side and doing the same thing to the right. And since I have fractions, it might be nice just to put this as 15 over 1 times whatever is left over. So in my first set of parentheses, I'm just copying down the x plus 2 over 3 minus 2x plus 1 over 5. And this is less than or equal to, and then on the right side, I have 2x minus 4 all over 5. So you could, again, put a few extra steps in here. I think I will write it out, where this 15 over 1 gets multiplied in front of both of these first two terms. But over on the right side, it's really just kind of set up where I can remove the parentheses. So to write that entire thing out, I get 15 over 1 times x plus 2 over 3. Now it's going to be minus. I have 15 over 1 times 2x plus 1 over 5. And this is less than or equal to, and I'm just writing this as 15 over 1 times 2x minus 4 over 5. So you could really start at this step where you're just placing a 15 in front of every single term. Okay, so as my next step, I'm going to try to cancel any common factors. So I have a 3 and a 15, one in the numerator, the other in the denominator. So those cancel to just a 5 left over. Very similarly, we have this 5 goes into itself once and into 15 3 times. And the very same thing happens on the right. 5 goes into itself once, into 15 3 times. And I'm going to be careful when I write down this very next step. This and this, those two fractions are multiplied to each other. So I want to be careful and just say, I'm going to put some parentheses around all of these terms. So that is, I have 5 times x plus 2 minus 3 times 2x plus 1 is less than or equal to 3 times 2x minus 4, like this. And now it kind of just looks like the previous question where, I got some numbers, I'll multiply them into the parentheses and see what's left over. I get 5x plus 10 minus 6x minus 3 is less than or equal to 6x minus 12. Okay, so combining the like terms. Okay, on the left we have a 5 minus 6x, so that's a negative x. Then we have a 10 minus 3, which is a positive 7, is less than or equal to, okay, and I have 6x minus 12. All right, so I think for this one, I'm going to subtract, it doesn't really matter which I do first, but I'm going to take 6x from both sides of this inequality. Again, this does not affect the less than. So I get negative 7x plus 7 is less than or equal to negative 12. Okay. So from here, that means, I'd have to now subtract 7 from both sides of my inequality. And I get negative 7x is less than or equal to negative 19. So we're not quite done. I still have to divide by the number that's in front of the x, which the way I did this, I was putting the x's on the left, and it just turned out that that's a negative value. So, okay, I'll copy this over here. And we had negative 7x is less than or equal to negative 19. I'm dividing both sides by negative 7. And I do end up with x on the left. I have a positive number on the right. That doesn't really simplify nicely. I can just write that as 19 over 7. But what does change here, and that's important, is it's greater than. And the reason this happens is because we're dividing both sides by a negative number. This is essentially a shortcut. This sign flips to make sure that the inequality still holds true. That's our final answer, and that's it for this lesson.